Hello everyone, today we will be simplifying this fraction with huge numerators and denominators. So this is our first method, 363 over 627. The first method is just to try some easy factors such as 2, 3, or 4, those very small numbers. So both of them are odd, so therefore none of them are divisible by 2. But how about we try the number 3? So do we all remember the divisibility rule of 3 is that if the sum of the digits of that number is divisible by 3, then that number is divisible by 3. Here, 3 plus 6 plus 3 is 12, and 12 is divisible by 3, so 363 is divisible by 3. 6 plus 2 plus 7, that equals 15, and 15 is divisible by 3, so 627 is divisible by 3. So therefore, we can do 363 divided by 3, that's 121. Divide top and bottom by 3. And 627 divided by 3 is 209. It may seem like we're done, but not quite. So here, we can notice that 121 is a perfect square. So this equals 11 squared. Therefore, the only number we need to try really is 121. Well, 121, well, clearly doesn't work because 209 is clearly not divisible by 121. But how about we try out 11? If we try out 11, you'll notice that 209 equals, this is actually 11 times 19. So therefore, the top and bottom, the numerator and denominator, is actually divisible by 11. And therefore, after dividing the numerator and denominator by 11, it is 11 over 19. So this seems like less steps, but this is only because the numbers are convenient, because we were able to find a common divisor that's conveniently very small, which is 3. We also are lucky with this number 121 because we know that from our heart that 11 times 11 is 121. But now we are going to be exploring a method where what happens if these numbers are not as convenient. And this is what we call successive subtraction, or Euclidean algorithm. Euclidean. So essentially, if we want to simplify this problem, well, this is the same thing as finding the greatest common divisor of 363 and 627. So we want to find the value of GCD, 363, and 627. And what Euclidean algorithm states is that if we have, let's say we want to find the value of GCD, AB, where A and B are positive integers, and we also have A is greater or equal to B. Okay, well, if A equals B, then the greatest common divisor would just be B. So we have A is greater than B. And this actually equals GCD, A minus B, B. So this is what Euclidean algorithm says, and we call it successive subtraction is because if this is not clear enough, if we can't really still eyeball it and find this value, well, we can continue subtracting whichever number is greater or smaller. So this is also why we also call it successive subtraction. So applying this algorithm right here, well, 627 is greater than 363. So we are going to do, let's not put the equal sign here. We are going to do GCD. So this will equal GCD 363. So 627 minus 363. So that would be 264. Well, we still can't really tell what the GCD of this is. So we are going to repeat. So here, 363 is greater than 264. So therefore, we are going to do 363 minus 264, which is 99, 264. And we do the same thing here. So that would be 99 minus 264. 165. We'll do the same here. So 99 goes here. 165 minus 99, that would be 66. And 99 minus 66 is 33. And finally, after subtracting 33 from 66, you get this, GCD. So, in other words, the greatest common divisor of 363 and 627, well, this will equal 33. So this means that both the numerator and denominator will be divisible by 33. So we just have to divide the numerator and denominator by 33. And as a result, 363 divided by 33, you'll get 11. And 627 divided by 33 is 19. So you'll get 11 over 19 as your final answer. So you may notice that this is a lot more steps than this one, but so first you can check this method, but if this method doesn't work, we will be using this method, Euclidean algorithm. And the reason why we use Euclidean algorithm is that we can apply this algorithm to basically any number, like numerator or denominator. But this one, it may not work as well because it may not work for numbers that are not as convenient as these. So this can be extended to like more difficult to work with numbers. But if the numbers are convenient, stay with this method because this will save you a lot of time. Thank you guys for watching.